Okay, first of all, can you hear me all the way to the back? Yes, good. Wow, I think I finally, for the first time in my life, I found somebody who goes through slides faster than me. So okay, so I'm Dafna. This project is called Accelerating Innovation Through Analogy Mining, and it's joint work with my student Tom Hope and with my collaborators from CMU, Nikki and Joel Chen. Okay, so let's start with this guy. How many of you recognize him? Edison, yes, this is Thomas Edison, also known as America's greatest inventor. He's responsible for many inventions that you've heard of, like the phonograph, the motion picture camera, and the practical light bulb. And the reason I had to say explicitly the practical light bulb is that while I was researching stuff for this presentation, I realized that the internet has gone completely insane over the question of who should get credit for light bulbs, whether it's Edison or Tesla. And when I'm saying completely insane, I'm not joking. Okay? You can even buy a t-shirt supporting your favorite inventor. But let's get back to Edison. So like I said, one of the most important inventors ever, and I recently came upon an interview held with him where he talks about what makes somebody a great inventor. That's why Edison said that working out an invention, the most important quality of an inventor is almost plenty of strawberries. Okay. The second, well, the second is a bit more vanilla. It's imagination. You imagine something that doesn't exist yet. What really got to me is the third thing. Edison said that the third essential is the logical mind of analogy. Now, by the way, the next paragraph is too good to not be shared with you. Okay, bear with me for the next slide. He said the logical mind is analogy, and then he goes on to say, no, not mathematics. No bit of mathematical hybrid ever invented anything that amounts to math. And then he said, goes on and said that he himself doesn't know anything about math, can't even do proportions, but he can hire all the good mathematicians that he needs for a week. Okay, but again, a logical mind is the third essential. And he does have a point. But throughout history, lots of important inventions involved analogy. The ancient Greek made analogy with water waves and sound waves, the Wright brothers, Edison, many of the documented analogies. My recent favorite example is this car mechanic. What with YouTube videos, part of it, I took some fork from a wine glass. And then he went home and made an analogy and created this crazy device that helps babies that are stuck in the birth canal. Okay, that could potentially save millions of lives, and again, just because he watched a stupid YouTube video and made an analogy. Okay, another interesting thing that happens is that there is an explosion of online idea repositories available. Okay, the USPTO has millions of patents just out there, websites like Innocentive and OpenIDEO and Kickstarter, scientific publications. So what I'm trying to say is that there is an unprecedented opportunity to use all this data and actually mine analogies that, like I was trying to tell you, can hopefully accelerate innovation and discovery. So my goal for this talk is to come up with a way to automatically discover analogies in such large, unstructured, messy, natural language kind of data sets. Okay, you with me? Good. So let me tell you a bit about analogies. First thing you need to know, they're really difficult for humans. Okay, first of all, going through millions of patents is daunting. But also, if you look at cognitive psychology, there's lots and lots of research said that humans are bad at it. That's a heavy cognitive load, and people tend to gravitate to surface similarity, or what's called near analogies. Meaning, this is a cell phone, this is also a cell phone, ooh, they must be analogies. Okay, and nothing too deep, nothing about the relations. Now, analogies are also hard for machines. So let me tell you about what's been done. So early days of computational analogy relied a lot on handcrafted data sets, high relational structure, things like this. Okay, this is how you would encode the example of the cork stuck in a wine bottle. And this is, by the way, the simplified version, because the full thing just didn't fit on a single slide. Okay, so you can see this is super hard to obtain, needs trained people, they make mistakes, most definitely does not scale. Now, recent methods, there's been lots of progress in natural language processing and information retrieval, but all of those methods also gravitate to surface similarity, right? And they can't really find things that are similar on a more abstract level. Okay, take for example this product, how to remove ice from a car windshields. So none of these methods will find an analogy or similarity to this thing that helps you remove oil from a frying pan. Although on an abstract level, it's exactly the same idea. You have two surfaces, so you want to get rid of one without hurting the other. Okay, but today's methods can't really do this. Okay, so let me tell you about how we try to do this. First thing I did was I come from a learning background, so how about try supervised learning? The data set we had was something called Quirky. You can think about it like Kickstarter, right? It's a crowdsourced innovation site. And we crawled 10,000 products across many categories, because again, we want cross-domain analogies. And those ideas are often expressed in natural language, or more likely, really, really bad English natural language. And this is just an example of what a product looks like. And what we did is we tried to actually get labels for what's a good analogy and what's not using crowdsourcing. Okay, so we built a search interface over quirky products. So we would show users some seed product and ask him to go and find us analogies in other quirky products. Okay, so they would type something, see a list, and they'll be able to mark things that they think are good analogies. Then we took the system and we basically recorded all the behavioral traces. Okay, the positive examples, the negative examples, which are really implicit, but I'm not going to go into this, the query, the timestamps. Every time somebody breathed near a keyboard, we recorded something. Okay, and the goal was to use all those signals to train supervised learning models. So it's been, 5 minutes into my talks, and I haven't said deep learning yet, so not cool. So, of course, we try to learn a similarity metric reflecting analogy. So similar products map close together, non-analogies map far apart. We use the Siamese network. Again, not going to go into the details. I'll just give you the bottom line. And the good part was that if you take all of the pairs in our test set, and you rank them according to the similarity metric that we learned, you look at precision at k, say what happens at the very top 2% of the ranking. So we get 64% of positive labels, while random baseline should get something like 11. We also beat some of the more standard baselines. So this seemed good. Bad part is that we decided to completely and totally abandon this approach because we took a close look and we didn't really trust the data anymore. Okay, so updating those labels, so first of all, super expensive, super slow, but also really noisy. Okay, so when psychologists told us that people are bad at finding analogies, they were not joking. People were really, really horrible at this. They did tend to gravitate towards surface similarity. Again, this is a phone, this is a phone, let's mark them as analogies. So even if we were getting something, I wasn't even sure that we were learning what we're trying to learn. Okay, so back to the drawing board. Let me tell you what we did next. So if you remember at the beginning, I told you there's really a spectrum between those crazy logic-based representations that's really hard to obtain, but once you have them, finding analogies is easy, and raw text, which is basically free, but you can't really do much with. So we said, how about we try something in the middle, some weak structural representation that's expressive enough to actually help us find analogies, but easy enough so we can actually learn it from data. Okay, and we landed on this idea from cognitive psychology called purpose and mechanism. And the idea is that analogies are really, really deeply related to the purpose of the product and its mechanism. Where purpose is what is it good for, what's the goal, and the mechanism is how it actually tries to achieve this goal. Okay, for example, the goal of this place, and the purpose is to remove ice from cars, and the mechanism is a brush and a blade and a grip. Okay, good. So the nice thing about purpose and mechanism is that if you do know them, it allows you to ask some core analogy questions, like find me another product that has a similar purpose, but uses a totally different mechanism to achieve it. Again, like the car and the frying pan. Or the repurposing question, the second one. Find me another product that has the same mechanism, but uses it for a completely different purpose. And by the way, this is my favorite example. It's kids floating, water wings. For a swimming pool, you put them around a wine bottle in your suitcase so it doesn't break. Total brilliant repurposing. Okay, so we wanted purpose and mechanism to be able to do this kind of thing. Okay, so we went to Mechanical Turk. We showed people product descriptions, some quirky, and we asked them to annotate what's the purpose, and how does it work, and what is it good for. Okay, so you can see this amazing pillow. How does it work? It has a pillow, an alarm clock, and Bluetooth and sensors, and so on. And what is it good for? Improve and monitor sleep, wake up comfortably, track sleep patterns, and so on. Next thing, we needed to create targets for the learning. Okay, so it's not really a sequence-to-sequence problem. I don't care about the actual words. I wanted to get like one vector that represents the overall purpose and the overall mechanism. Okay, so we did this really popular trick recently that's taking glove vectors, weight them by TF-IDF, and call this our target. Okay, and 5 more minutes, 1 more deep networks. So all I really want to tell you is that this bidirectional GRU RNN that tries to predict both the purpose vector and the mechanism vector. Details in the paper, KDD last year got best paper. You should be able to find it. Okay, one thing I really don't like about deep net, if we're already talking about it, is you're never really sure that you learn the right thing. Those things are not super interpretable. So what we try to do is a quick reality check. Okay, we took those vectors, the purpose and mechanism vectors that we learned, and we said, how about we treat them as a sparse linear combinations of words, and see what those words would be. Okay, so for example, this little yogurt maker, you learn the purpose, you learn the mechanism, and the top words for purpose are making energy in yogurt, and for mechanism it's vacuum, cooled, and drown. And we did this for a bunch of other products. So, okay, not the most rigorous analysis I ever had to do, but as a reality check, the purpose words were indeed more about the purpose, and the mechanism words were of a more mechanical nature. Okay, evaluation. First evaluation was pretty much what I showed you earlier. You take a lot of test pairs, you try to see what the ranking comes up with, and we did beat all the standard retrieval outlines, baseline. But this is actually not the fun evaluation. The evaluation I really want to tell you about, the one I'm excited about, is this one. So I spent the first 5 minutes of this talk trying to convince you that analogies are all about enhancing creativity. So this is an ideation test. It's actually standard when you try to assess creativity, where you show people some design problem and ask them to come up with solutions while giving them some inspiration. For example, we showed people this product from Quirky. It's a cell phone case that has a second battery in it. So it really extends the life of your battery. And we told them, find other ways to solve this problem. Find other ways to extend the life of your cell phone better. And in inspiration, there were 3 conditions. Random quirky products, because there's been studies showing that random is good for creativity. Surface similarity, which is trying to mimic today's search engines. And our baseline, which I'll talk about in a second. But the idea behind it, the hope really, was that random is going to be very, very diverse, but completely irrelevant to the actual problem. Surface similarity will be super relevant, but not really diverse, right? Everything is going to be about cell phones. And ours will be diverse, but hopefully still relevant. So it actually allows the user to explore more diverse part of the design space, parts that they wouldn't get to otherwise. Okay, so our baseline, just to be clear about this, we looked for things that have similar purpose but far mechanism. So clustering everything according to the purpose vector and diversifying by the mechanism. Okay, with GMM, it has some nice approximation guarantees. So this is from the actual study. Those are some snippets that we did get. So for the problem for extending the life of a cell phone battery. So surface similarity, the middle column, has a multi-adapter case, cell phone battery with GPS, cell phone case with GPS. So like we said, very focused, very narrow. Random is, of course, all over the place with shampoo pods and dog meat about. And our approach has stuff like a flash charge carabiner, USB tower with backup battery, and my favorite is right here. It's this completely crazy invention that's a suit with a system of pulleys inside that generates motion energy when you move for I don't even know what. Like something really insane. Okay, but you can see it's about like increasing battery life, just not of a cell phone. Then we went on, we did this for 38 mechanical Turk workers, and it was a within subject study. So each one of them was actually exposed to all the 3 conditions in different seed products. So just an example of some of the ideas they generated. I just want to show you the first one. So this guy was exposed to our baseline, and he writes a case that tracks steps and generates power using your movements. Now I don't know if he got this idea because of the crazy suit or not, but I really, really hope so. We took those ideas, we rated them by 5 judges according to criteria that are standard in creativity literature. So novelty means it's actually a different solution than their seed product. Quality means it's actually a solution, like it solves the right problem. And feasibility meaning no time travel or cold fusion or things like this. Okay, do not defy physics. And we had a nice agreement, we had 0.5 something. And results were that even if you look at proportions or absolute number of good ideas, our approach generated a nice, considerable, large relative positive effect. Okay, people were just generating better ideas and more of them, both absolute number, both proportion. Now we tried looking at it from another angle, adding explicitly modeling within participant and within seed dependencies, and results were the same. So basically, no matter how you slice and dice it, it seems like our approach yielded a reliable increase in how creative the participants became. Okay, so this entire talk, the whole point for me was to convince you that analogies are awesome, and especially for innovation and discovery, and that there is really interesting opportunity with all the big idea repositories that are available to us today. So in particular, we focus on this idea about how to use those weak representations of purpose and mechanism, which allowed us to find higher precision analogies, and also, more importantly, to help people become more creative in an ideation study. Okay, many future directions this can go to. First of all, other domains. I have a student working on patents. I might start working on corporate data. Lots of other extensions. We just had a paper, what was it, last week, 2 weeks ago, about injecting common sense into it and actually allowing people to explicitly choose the direction of analogy they want to do. Keep those aspects fixed, keep those, abstract to this level. Do you care that a soap has those chemical properties or not? Do you care that it's a personal product? So really help people kind of, because it's not just here's a product, here's an analogy with regard to each aspect. There's lots of other ways that this can go. If you have an idea, if you have another domain or anything, well, you know where to find me. Thank you. Questions?
So we have time for questions.
Yeah.
Trees method of Altshuler for
Yeah,
inventive thinking.
Trees and arrays and all those fun stuff.
Actually is against analogies. He thinks that it generates low-level inventions.
Yeah, I know. But, you can put him and Douglas Hofstadter together and let them fight it out. No, I'm not on this camp. I love trees, I really do. But from my experience, whenever I tried using analogies to solve something, it works really nicely. Here it seems to work. So maybe it's not for every kind of invention. But I don't know. It's more of an ideology question at this point, really. Did I do this? No. Okay. Yeah, exactly. Anything else?
Thank you.
Okay, thanks.